Hi everyone. Today we're going to study electrical circuits. First, let us familiarize ourselves to some words, their symbols, and respective units. The first is charge. The symbol is Q and the unit is coulomb. Next word is current. The symbol is I and the unit is ampere. Next word is resistance. We can see here that the illustration is like this. The symbol is R and the unit is ohm. For the inductance, the symbol is L and this is the illustration. The unit is Henry. Next word is capacitance. The symbol is capital C. This is the illustration and the unit is farad. Next is electromotive force or voltage that is constant. The symbol is constant capital V. This is the illustration and the unit is volt. Last is variable voltage. We have the symbol as variable capital V. This is the illustration and the unit is volt. The formation of differential equation for an electric circuit depends upon the following laws. First is the current, symbolized by letter I. This is equal to the derivative of Q with respect to T. Next, the charge of the capacitor. The symbol is Q. This is equal to the integral of I dt. Next, the voltage drop across resistor. We have capital R equals capital R times I. Then the voltage drop across inductor, denoted by capital L. This is equal to capital L times di over dt. Then the voltage drop across capacitor. The symbol is capital C. This is equal to Q over C. Let us study Kirchhoff's laws. The first is voltage law. It says the algebraic sum of the voltage drop around any closed circuit is equal to the resultant electromotive force in the circuit. Next, the current law. At a junction or node, the current coming is equal to current going. That is, the algebraic sum of currents flowing into or from any node is 0. Now let us consider this illustration. We call this LR circuit. Let small I be the current flowing in the circuit containing resistance capital R and inductance capital L in series, with voltage source capital E at any time t. By voltage law, we write capital L times di over dt plus R times I equals E. Let us divide this equation by L to isolate the di over dt. The new equation becomes like this: di over dt plus R over L multiplied by I equals E over L. We can see that this is a linear differential equation. We can collect the values of P and Q. The P is the R over L, that is the coefficient of the I, and the Q is the value on the right side, the E over L. We can solve this and remember that we have two steps. The step 1 is we compute for integrating factor or the IF. The formula is e raised to the integral of p dt. After that, the step 2 is we compute for the general solution. And this is the formula. I times the IF is equal to the integral of the product Q times IF, then dt. What about the RC circuit? Let I be the current flowing in the circuit containing resistance R and capacitance C in series with voltage source E at any time t. By voltage law, we write R times I plus Q over C equals E. Remember that Q is equal to the integral of I dt. We substitute this value in the Q. So we have now this 1 over C times the integral of I dt. Let us differentiate both sides with respect to t. So it becomes like this, R times di over dt plus I over C is equal to dE over dt. In here, let us divide by R. So the new equation becomes di over dt plus 1 over RC multiplied by I is equal to 1 over R times dE over dt. We can see that this is a linear differential equation. So it means we can collect the values of P and Q. The P is this 1 over RC and the Q is the right hand side 1 over R times dE over dt. Same procedure, we're going to go for step 1 to compute for the IF. The integrating factor, this is the formula. After that, we compute for the general solution and this is the formula. Let us see this example. An inductance of 2 henries and a resistance of 20 ohms are connected in series with an EMF E volts. If the current is 0 when t equals 0, find the current at the end of 0.01 second if E equals 100 volts. We can draw our given here. By voltage law, we write L times di over dt plus Ri equals E. Let us divide this equation by L. The new equation is now di over dt plus R over L times I equals E over L. Please observe that this is a linear differential equation and we can collect the values of P and Q respectively. The P is the R over L while the Q is E over L. So when we go for step 1, that is, we compute for the integrating factor. This is the formula, E raised to the integral of P dt. The value of P is here, the R over L, so we substitute it here. Then we simplify the integral of R over L dt. It becomes R over L times t. So the value of IF is E raised to R over L times t. Then the step 2, the general solution, and we use this formula. We copy the I and we substitute the IF and the Q respectively. So the equation becomes like this. We copy the left side as is. On the right side, this E over L is a constant. We can pull it out of the integral. Let us take the integral of this E raised to R over L times t, then dt. So the right side becomes E over L, and this is E raised to R over L times t all over R over L, then the constant plus A. Let us simplify this complex fraction. Let us take the reciprocal of this R over L. So it becomes like this. So we have here E over L times L over R. We can simplify the two fractions by cancelling the L. We can combine on this E and the denominator R, and it becomes like this. Next thing to do, let us isolate the I, which means let us divide this equation by the quantity E raised to R over L times T. And if that happens, the new equation becomes like this. I equals E over R plus A times E raised to the negative R over L times T. This is now equation 1. In the given, it says at t equals 0, I equals 0. Let us substitute the values in equation 1. So equation 1 becomes like this. The left side becomes 0 equals E over R plus A times E raised to the negative R over L times 0. The 0 here in the exponent will multiply to the negative R over L, and this is equal to 0. It means the E is raised to 0, and that is equal to 1. So we simplify this equation now to be 0 equals E over R plus A. Let us transpose this E over R on the left side, so the sign will change. Then the value of A is derived. It means to say the value of A is equal to the negative of E over R. This value we will substitute in equation 1. So equation 1 becomes like this, and we can simplify this further because E over R is common in the two terms. When we factor out this E over R, it becomes like this. Then this is called now equation number 2. Next thing to do, going to the given that R is equal to 20 ohms, then L is equal to 2 henries, let us substitute the values in equation number 2. So equation 2 becomes like this. We can simplify this further because we have this 20 over 2 in the exponent that we can simplify, so it becomes 10. So the E here is raised to negative 10t. This is now equation number 3. Next is at t equals 0.01 seconds, the E equals 100 volts. These values we can substitute in equation number 3. So equation number 3 becomes like this. Let us simplify some parts of the expression. This 100 over 20 is equal to 5. When we multiply 10 by 0.01, it will be 0.1, which means the E here has the exponent negative 0.1. Using the calculator, we can take the value of this E raised to negative 0.1, and the value is 0.90484. Inside the grouping symbol, we can take the difference of the two values, and the difference is 0.09516 that we can multiply with a constant 5 outside. So I is equal to 0.4758. So I is a current, so the unit is ampere. This is the final answer. I hope you learned something from this video. See you again next time.